There seems to be a problem. So I am recording it, then I upload it to the channel. I think that's better. Yeah, I hope it will be recorded properly. Okay, so whatever the symbol you are accustomed with, you can just replace it with. Suppose you feel that I am used to with this, and you might have used some other notation and you have developed a formula for that. So if you feel that is comfortable, you do that immediately. Okay, you just take it as a kind of tips. Okay, so convolution, I hope you all know that, but I'm just repeating it for one thing. Okay, so first thing, what will be the size of the output? That is what you need to determine. So that helps you whether you have made a right calculation. Okay, so I have an input shape of 4 by 4 and kernel size of 3 and stride 1 and p0. Then what will be the output shape? I need to compute the convolution sum. Okay, let me call it as A. So what will be the size of output? The future map A, you know that formula, right? What is that?
W minus F plus
Okay,
2
so
P
the
by S
width and
plus.
height, right? So we use h and w in case. So here it is 4 by 4. So it is 4 minus the filter size 3 plus padding. So no padding. So it is 0 and then stride is 1 and then plus 1, right? So the answer is, what is that? 4
2.
minus 3, 1 plus 1, 2 by 1, 2. And same is true for h. So both height and width is going to be 2 by 2. So if I compute something, right, after doing this convolution operation, I should end up with a matrix A or a feature map A of size 2 by 2. Okay, so that this is just a way to ensure that you are doing everything correctly. And then here also note that as I keep on telling you that the most of the elements in the matrix, okay, not only in this problem, in any problem, we tend to come up with some simple numbers. Okay, oftentimes there will be more zeros and then ones and minus one. Okay, so the intention is you should make the calculation quickly instead of relying on the calculator. So you may not see some decimal numbers as an input, but the output could be a decimal or floating point numbers, but the given inputs are going to be some has some spot structure. Okay, so one immediate thing that you could notice is that it is going to be matrix element wise product, and one of the rows of this f is completely zero. Okay, so you need not to compute anything. So you place this kernel on top of this for the to compute a. Let me say this one is a00. I have to compute a00, a01, and a10, a11, right? So to compute this, I have to place this kernel on top of this x, and then I just keep moving it, right? And you explicitly write everything in your paper. Okay, do not do any mind calculation. That will end up, either you end up doing some mistakes if you do everything as a mind calculation. I'm just writing these elements 100, 0, 1, 1 and 202, but being aware of the structure that one of the rows of f is, it's completely zero. Now what should I do? It is going to be simply multiplied with this, and then we are going to sum it up, right? So what really happens is that I have minus 1 here and then 1 here, so it is going to be minus 1, and I can completely ignore all these steps. So it is going to be plus 0 plus 0 and then plus 0 and then plus 1 plus 1. Okay, then I can completely ignore this row because all of them are going to be 0. Okay, and what will be the result then? Minus 1, then plus 1 and plus 1. So the answer is going to be 1, but it is not exactly 1. So there are two ways, because we need to add bias after each computation. Okay, so for all the kernels we have the bias associated with it, so we have to add the bias. When you start computing all these elements a00, a01 and a10 and a11, okay, and I need to add bias to each of these output, right? So if you keep doing that, you will end up with a matrix. Okay, so I assume 1120 something like this. Okay, and you need to add bias to each of these elements, so you can simply add it. Okay, so you might have adapted some approaches. Okay, what is the bias value? It's 0.1, 0.1, 0.1, 0.1, 0.1. Okay, either you could have added the bias in the immediate output activation, immediate output of this particular expression, or you can do that later as well. Both of them end up in the same result. So this is 1.1, 1.1, 2.1, 0. So answer is, what is the answer? 2, 3, 4, then 4.4, right? So far everything seems like this is fine if you are just asked to compute this convolution sum operation, because this is a matrix multiplication, all these stuffs. So you will encounter a problem when you try to compute the gradients. Okay, so but anyhow, as a first step you end up computing calculations like these, and we just proceed. Okay, I don't want to write down the expressions, I calculated the answer, so I'm just going ahead. Okay, so here then we have a feature map A. So the next question asks you to, okay, something called as max pooling layer. That's fine. Okay, so some max operation is being taken with the kernel of size 2 by 2. Okay, the result is then passed as an input to the sigmoid or logistic function. Typically it is always going to be, when we use this word sigmoid, you just assume this as logistic sigmoid. Okay, so it is always going to be 1 by 1 plus e power minus z formula. Okay, no other formulas. Fortunately, my A is of size 2 by 2 and the kernel size is also 2 by 2. So it is going to be a single operation, even though we call it as a max pooling layer. But since my A is very small, 2 by 2, the output is going to be a single number. Okay, so you have to first take the max operation for A and then pass the result to the sigmoid function, which is straightforward, right? So what is the max of A? So you have to look at here. Okay, it's 2.1. So the better thing is you note down the index of it. So it is A10. Okay, then you pass this value, which is sigmoid 2.1. This is not going to be a problem. You compute, I think answer could be somewhere around, what is the answer? Do anyone have an access to the answer? Let me take a look. What is sigmoid of?
0.89.
So it's 0.89. Is that?
Yeah.
The 0.89, yeah.
Okay. So now it is 0.89. I am happy with that. Then I am just scrolling down to see what the next question is. Okay, so you see of course, this is one of the big mistake I made in the term 1, that assigning high mark for a single question. Then later I break it down into some intermediate step. But typically you see the maximum weightage is around 5 to 6. Okay, which means we can't break it down further. So we have to be very careful. I have no other option to, other than asking these 5 to 6 mark questions, because it's quite tough to break down that question and ask it into parts. Okay, but you won't see this sort of things, assigning 10 marks for a single question. Okay, now the question is, suppose the gradient of the loss with respect to y, okay, is 1. It should be y hat, but here we denoted it as y. We denoted the output as y, so it's all right. Let's keep it with y. Remember, in the exam we are always focusing on the toy setting. Okay, so what is given is dou L by dou y is -1. Okay, so update the parameters of the kernel, okay, which is f, or let's assume you assumed it as w. Okay, I have w of size 3 by 3, and you can give index of your choice, w00, w02, all the way up to w20, w22. Okay, so I need to compute the gradients for all these, each individual elements of w. Okay, and learning rate, of course, it is specified as 1, assuming that, suppose we forgot to specify the learning rate. Okay, there you have a, choice. You can put this as any number you want, but safest choice is keep eta is equal to 1. Okay, of course you can go with any number, but I would prefer the simple numbers, okay, otherwise it blow up your calculation. So take it as equal to 1, okay, then it is our responsibility to provide you the marks. Then enter the sum of the updated parameter values. Okay, so this is what I typically did in the previous terms, but again, now I could ask you, you take w00 instead of asking you to update the parameters and enter the sum. I may just ask you a single element. Okay, what is the value w00 value after a single iteration? Okay, so it is just to the intention is just to evaluate your answer in some way. Okay, so we have to bring up it to single number, so we may ask you either sum or just a single number, so you have to be very careful with that, what is being asked. Okay, whether it is sum or just a single number from the matrix. Okay, and if you ask you the single number, then we have to give you the index notations as well, whether the index is starts from 00 or 11. Okay, so all these things information, all this information should be given in the question. If it is not, then the mistake is ours. Okay, okay, let's go with the solution. First thing, I need to compute the gradient of all the parameters. Okay, so to compute, then first let us start with w00. Let us say I want, of course in the exam it is f. Okay, now I am preferring w because I am comfortable with that. So I want to compute uh, the loss with respect to w00. Okay, so one thing is, since it is a toy setting, you can see what are all the operation you have carried out so far. You can write any pictorial representation if you want. That is good thing. Okay, so the first step what we have done is that I have computed a matrix A. Okay, writing the explicit equations will give you a right direction how to move along, right? So I have computed something a10, let me see, a00, a01, a10, a11. Okay, since now I'm asked to compute the gradients, I should write the explicit equation for this a00, a01, a10, a11. Okay, then only I can compute the gradients. Okay, so it is, how do you compute a00? What is the equation if you want to write this down as an equation? Okay, let me come back to that later, even a bit later. Let's see the entire operations. Then what the next operation is something like I applied max of a, right? Okay, so which means I took max of this entire a00, a01. Remember, I assigned 10 points, which means you have 10 minutes approximately. A11. Okay, and I'm going with the real calculation. So in the real calculation, the index of the element is max of a is a10. Okay, so this is the max results. Okay, so I took a10 as an output because that is the max, and computed sigmoid. Okay, so which is equal to y. So this is a sequence of operations we applied from the input all the way up to the output, right? So now in order to compute dou L by dou W00, what will be the expression if you really want to write down the expression explicitly? How do you write that? You are given dou L by dou Y. Okay. Then what do you, how do you go about the next
Dou
term?
y by dou a is given 0.
Dou Y by, yeah, you can go with dou A10, or since it is a max operation, you can, in the immediate first step, do max of A. Okay, in this toy example, that's fine. Anyhow, max of A is going to be A10, and then do again max of A divided by, what is that?
Do A actually. Do A00.
Which one?
You're doing for W00, right? So max of
Yeah.
A divided by do A00.
Now we are computing everything with respect to this parameter, right? I mean, eventually you want to say how when W00 changes, then A changes, all these things changes, right? So,
No, still it won't be dou max of A max of A divided by dou A00 and then dou A00 by dou W00. I'm just being pedantic.
okay, yeah, that's correct. How all these term, the entire term changes A, but A by W00. Okay, that's correct. Okay, I'm not sure how to delete that. Okay, there will be additional term. Okay, all these terms. Okay, so somehow we have written some expression. So here the quantity is given, and of course you can, since here you can simply replace max of A is a single term. Okay, if it is a max pooling layer, then we have to compute for all the 4 terms. Like in quiz 2 of term 2, you might have seen some max pooling layer, 1D max pooling, where you have, I'm just to compare, I'm doing that. Okay, so you have some input, one dimensional input, and then you take a max, and then you will have 4 elements in it. Okay, this is just an extension of this concept to one dimensional or flattened input. Okay, so what are all the quantities I need to compute here? Okay, let me rewrite this expression: dou L by dou Y, then dou Y by, here max of A is A10, so A10, and then how A10, what is that? A10 changes with respect to, do you understand? I mean,
Yes, sir.
what should I do? Do A1, how do A10 changes with respect to what?
Dou W00. Here you can write dou W00.
Okay, so we have given this value, it's sorry, it's at -1, right? I hope so.
It's -1, yeah.
Yeah. So I need to compute two quantities. Okay, dou Y by dou A10 and dou A10 by dou W0. So I need some expression for that. Okay, so I need to write the expression for A10. What is the expression for A10? Of course, you have used matrix. You slided the kernel and computed all these quantities pictorially. But what could be the expression for A10? I have A. Let me go to this given input. Okay, so I have computed, the end result is 2, right? But what is then expression that gives me this 2? How do you write that mathematically?
It
This
will
is
be
A10.
x offset by 1 star
Sorry,
f.
X.
How do you offset by 1? Because we have
X10.
the second, yeah.
Okay, let's first address on this. I have X, so let's say the index is 0, 0, this is 0, 1, 0, 2, 0, 3. Okay, if I use this index x 0, 0, 0, 1, 0, 2, then you tell me the expression. This is W0,
Yeah.
X10.
X10
X10.
W00
Okay, then
plus X11
W.
W01
Okay, so all the way up to the final term will be
uh,
x2
23
x2 no x22
22 22
X22
star
W.
fw022, yeah, or f022, yeah, whatever.
Okay,
W22
000110, sorry, 00102022, right? W22. So I need, this is a very typical thing, right? So in fully connected layer also we compute only this dot product. Here also it's a dot product. So I have an expression for A10. So that quantity requires me to compute do A10 by do W00. So if you take a derivative of this, you will end up with what?
Only the x10 term.
So we have this x10 term. Okay, so what I observed in the first term, okay, the from the feedback I received from the term 1 student, okay, is that they stuck at this point. Okay, because in the assignment they applied the concept of this of course, both are same. Visually, you place this kernel over this and then multiply, you will get a result. Okay, but even in the assignment question, you are supposed to compute the gradient. So somehow you end up writing this question equation explicitly. Okay, so if you write down everything explicitly, then you can see how things works. So it is just going to be, the input. Typically it is always going to be the input, right? So I need to note down what is the value of x10. What is the value of x10? It's 0 0, and it is this is x10, which is equal to 0. So now I observe that this is 0. So once I observe this is 0, then do I need to come? Of course, this is a chain rule. I am observing this quantity as 0. Okay, so this quantity turns out to be 0. This is always going to be my input. Okay, so all the elements are going to be from the input matrix A. Okay, and you need not to, from the computation perspective, you need not to compute the rest. Okay, because all are a product term. So you are observing this is 0. So everything is going to be 0. So my gradient for W00 is going to be 0. Okay, but what about the gradient of the bias? So we need to compute the gradient for the bias as well. So if I go with the similar expression, what will be the, how do you compute the, here it is W00, W001, and then the right expression is that we are adding bias as well, right?
Yeah, plus B1. The end.
Yeah.
I mean, there's only one bias, so you can give any name to it.
Yeah. So in that case, what will be the x? If I take the derivative with respect to B,
It'll be
same
1.
quantity. So it is going to be 1. Okay, and this is true for all this, right? So I can even write though ij for any element, my bias is going to be 1, right? If I take, you can take either a10, a00, a01, a11, whatever. So you will end up with the value 1. Okay, so of course for this problem, whether we need to generalize this, it doesn't matter, but I'm just telling this as an additional info. Okay, and by the way, so is that fine so far? How we are proceeding to compute the gradient of the kernel, elements of the kernel, or do you have any specific doubts, or which, otherwise I can proceed.
Yeah, please proceed, sir. This is clear. Yeah.
I want the response from the all. So almost some 14 students are here, so you can at least give this thumbs up, right?
Sir, we are calculated just now dou A10 by dou W00, right?
Yeah, what we have calculated is for this only this quantity W00. So what do you think? What will be the next steps? So this turns out to be 0. So yeah,
We know that 3 terms will be
See,
0. Only one term we have to calculate actually.
So what you can do is that this is fixed, right? This is going to be same for all the parameters W00, W01, W10. What do you think about this quantity?
That is the derivative of sigmoid function.
Yeah, that is the
It's
derivative of
fixed for
sigmoid
all.
function.
Yeah.
Again, same for all.
Yeah. So of course, if you compute this, that what is the input? Sigma of A10, 1 minus sigma of A10, and you will end up with some number, right? So let's say, what is the number? Do anyone knows that?
0.909, 0.89 into 0.11.
So it will be around
0.09.
0.09. Okay. So this quantity going to be these two quantities, right? These values will not change. So for dou W00, dou L by dou W00, I have computed the values as -1 into 0.09 into 0, which result in 0, right? And for dou L by dou W01, these two quantities will remain same, right? because the expression remains same. Can you tell me why this quantity remains same? Can you guess that?
I actually had another, but I'll say Srinivas because the first two terms are the same for all the equations. But one more thing I want to request Arun, is that this question, right? People are posted, right? If you take the second, third decimal place, the answer changes. So you had clearly said use two decimal places, so you may want to mention that also.
Yeah. So in fact, in the last two terms, I was mentioning this how many digits you need to consider. But the problem the students face is that they need to. So it is kind of they stuck at that point, right? So they have to note down all these values, truncate this. So they felt as if they are adding an additional, doing an additional unnecessary kind of, operations. They have to be mindful about all these things. So what I did in this term is that you take minimum two digits, that is sufficient. Even if I if you have answer like let's say 1.001012, something like this. Okay, so typical thing, of course, it is fine, absolutely fine if you just stop with 1.00. But if you feel that, say for some reason, I consider this digit as well, that's also all right. So I just increased the range. Okay, so if I got the answer, exact answer as 0.5, okay, and I increased the range to something like this 0.4 to 0.6, and then I just recalculated, considering I always considered at least minimum two digits. If someone feels I consider at least one digits, that's also fine. Suppose if they feel there are a lot of calculations, but you should not round it up, right? It is like I only go with one instead of 1.001. That is not a good way. So I leave it to the students. Okay, at that point of time, if they feel they need to just keep 2 points, absolutely fine. If they feel they need to keep at least three decimal points, that is fine. Okay, so I don't want to put that constraint, the which kind of you need to keep track of that. That's why I removed that constraint. Suppose following all these steps, if your range goes out of, or if your answer goes out of the given range because of this reason, I can modify it. Okay, so please ignore that. You don't. It is not when you refer to the answer key, and if your answer is not within the range, it doesn't mean you have made a big mistake. Okay, so you can just tell me in the discourse that I consider only two digits, and after considering only two digits, my answer is not within your range. Then I will relook at that, and then I change the range. Okay, so I don't want to put that constraint in any of the questions. Does it make sense? Otherwise, this will be an additional burden. That's what I received as a feedback from the previous term students.
Sure, I understand. Yeah. Yeah, in this case, what happens is that this term 0.09 gets actually added 8 times. So even if you have 0.093, the truncation, non-truncation makes a difference in the end.
Yeah. So that's actually a problem. I mean, I should not have done that. And fortunately, we can award partial marks, and that is possible only if it is a NAT question. So that's why I prefer NAT question. Okay, because if it is an MCQ or MSQ kind of questions, if we found some ambiguities or if students found some ambiguities, right, we have to drop the question altogether. Okay, and, but if it is a NAT, we can, if it is a reasonable concern, then we can, award partial marks, so there won't be much problem. Okay, so out of 10 minutes, you might have spent about 5 minutes on figuring out and computing the first quantity. Okay, but to compute the next quantities, you now see the pattern, right? So it is going to be, again, I just leave it to you. So it's -1 into 0.09 into whatever that, what is that value? What is that? Now I am computing with respect to W01. So I have to, the derivative is going to be x11 value, right? So you have to just keep plugging in all these respective terms, and then you will end up with the gradient for all the weights in the given kernel, right? And it is always better to write the gradient separately. Okay, all these values 0 and whatever you will. So if my kernel size is 3 by 3, I must end up computing the gradients, and the gradient kernel size will also be 3 by 3. So in this case, it's not a problem, but I'm just telling, right? And eta is going to be 1, so you substitute eta as 1. Okay, so sometimes mistakes happens in this stage. Okay, when you do all these things, when you update the parameter, mistakes might happen. Okay, but that's kind of inevitable. Once again, I give you an opportunity, you reproduce your mistake, and then I can award you partial marks. Okay, so this is for quiz 1 question, I'm sorry, quiz 2 of term 1 question. Okay, so the key idea I'm keep re-emphasizing is that you write everything explicitly. Okay, be it this formula or this one is quite straightforward. Okay, this convolution operation. Okay, so do not refer, and one thing is you keep referring to the some external resources, that is absolutely fine, but in external resources convolution, if you just look for the formula for general convolution, okay, if it falls outside of this convolutional neural network, if someone discuss about the convolution operation in general, the formula is entirely different. Okay, so they will flip the kernel, then they multiply and add the elements. Okay, so be mindful if you are referring to the other resources, okay, whether it fits inside the convolutional neural network, or that you have to check all these things. Okay, and if you are getting stuck at some calculation, please post it in the discourse. Okay, okay, so this is for convolution operation, and in the next question, yeah, so this is one, I mean, there is only 3 questions I'm able to see here.
The next question changed the sigmoid to ReLU and asked for the sum with the same value again.
Again, giving 5 more minutes. Okay, so the steps won't change. Okay, except that instead of this derivative here of this one, right? What is the derivative for the ReLU?
It is either 1 or 0. Yeah.
So that's quite simple compared to this one, right? And the trickier thing is in the max computing this max function. So what is the derivative of the max function? Suppose you are having some n elements. Okay, I want to take during the I have a max operation here. Some element matrix is fed in. It could be a matrix or it could be a sequence of numbers. I take a max out of it, and some output is coming. Let's say I denote it by m. Okay, then what is the derivative of this one? Let's say
Yeah, you asked us to hold the index. So basically, the derivative is 1 if the index is the same, or 0.
Yeah, so you can follow any index. Okay, so sometimes I have seen students, I mean, in their solution, they follow whatever they want to be. I mean, here I have written the elements as matrix. Okay, A10, A11, sorry, A01, A11. For some reason, they flatten this out, even though it is not required, but they feel some sort of convenience with this one. Okay, and then they figure out this is the max. Okay, so it's kind of whatever the thing that is at that point of time, if it is convenient for you, you can do that. Even I encourage that, because you are accustomed to doing all these things by changing all these steps in your convenient way, so you follow the same in the exam. And yeah, so other than this, only thing is you need to remember the derivative of the sigmoid, and maybe I can change the activation to tan h. What is the derivative of tan h?
1 minus tan h squared.
Okay, so for these activations, the thing is, the possible thing I could change is I can't change the convolution, the way convolution is defined. Okay, it is going to be same, so that component cannot be touched upon. Only thing I can change is I can change the activation function. And if the activation function is completely random, then I have to give you the derivative of the activation function, but I won't do that. So only activation function I touch upon is this sigmoid tan h ReLU adi. At max I could go up to leaky ReLU. Okay, I can't go beyond that, given that this is an exam thing. Okay.
One curious question. Suppose, right, two values contribute to max. I know we have had it, even the max have been both sides, it is the same, means a single value. But what if two values are the same? How do we look at the derivative?
So if two values are same, right? So let's say you are in a max pooling layer. I'm assuming you are asking with respect to a max pooling layer, right? Or even in general, it could be. So I have a
In a
matrix.
max pooling layer, because there's a single thing, right? Suppose they say 1, 2, 2, 3, right? So that's a thing.
Okay, so I have something like this.
Sorry, 1, 2.
It could be
Sorry,
anything, right? So I have
1, 2, 2, 1.
sorry. So you are taking max of A. So unfortunately, you have to take only one element as an output. Okay, so in that case, even in the implementation, okay, where you are writing the code, when you encounter things like this, okay, so you will toss the coin and pick up the one. Okay. In the exam, I have to ensure that there are no such situation. I mean, because I am making all the calculations, I have to ensure, there will be only one max value when you do this max pooling. There should not be more than one. Okay, but in an unfortunate situation, this is a tips. In case you end up with two max values, you might recheck your calculation. I try to avoid that. But in general, if there are two max values, then you flip the coin, pick up the one. That's how the CNN framework is even implemented in all the frameworks. So wherever they encounter more than one max values, so you have to pick up randomly, but you have to remember which one you picked up. You have to store the index of it. If I picked up this one, then I have to store the index of it, which is A01.
So for min also it will be that particular index value will be 1 and other 0.
Yeah, that is correct. Yes, if it is a min of this, even if it is an what is that, average pooling. So what will be the formula for average pooling? Because the core idea is I have a kernel with some 4 elements. I have to take only one element out of these 4. Okay, which means I can combine this also. I'm just for the sake of
For
completeness, I'm
average,
just.
the derivative will be 1 by n.
Okay, so your A1 plus A2 plus A3 plus, A01. So you just generalize. Okay, so how do you go about it? It is 1 by
1 by n, right? 1 by size, the number of elements.
Okay, so are you all comfortable with that answer, or agree with that answer? If it is an average pooling. Okay, don't worry. So we are just discussing in general. Okay, so in the exam, either you will, most of the time we end up with max pooling, but since it is a curious question, what will be the answer? Remember, in average pooling, we incorporate all the indexes.
So all will be 1.
Okay, so let me pose let's not discuss about this. I may take a question around this and post it in the discourse after the exam. Okay, because this might be some interesting thing to discuss. Not now, maybe. Yeah, Hanani.
Sir, in the last question of grade assignment 8, for that I saw a solution on discourse where the person has used the convolution operation while doing the backprop also. So
Sorry, convolution operation.
while doing the backprop.
Okay.
So I was trying to find that solution, but I could not find it. The way I solved that question is by laying out the expression, by writing out the whole expression. Then I found out the loss function with respect to W1. But I'm curious as to how he did it.
I didn't took a look at that one. I may take a look at and see. But thing is that if you if you understand the entire backprop in general, right? So here we are writing everything explicitly, that's fine. You do the same convolution operation, but you flip the kernels. It is exactly like it is like in the feed-forward neural network, right? If I have one hidden layer here, and I have a W matrix that connects with other hidden layer, so it is connected through a W matrix. Okay, so what really happens? So I have H1 here, and this is A2, and this is H2. Because how do you compute A2? It is W times H1, right?
Yes.
What is the gradient of H1? Or dou H1, let's see. Nebula H1. What do you do in order to compute the gradient of H1? Assuming that you have gradient of A2.
A2 with respect to H1.
The
Gradient
general
dou of
formula.
A2 gradient of A2 into dou of A2 by H1. So you want the general formula while doing the
What do you
backprop.
do with the W? You take W
I did not
transpose,
understand the
right?
question, sir. Yes.
Okay, so you take W transpose, which means the same thing. I mean, this convolutional neural network is no different from fully connected neural network. Only that weight is shared. Okay, so the weight is shared. So the entire backpropagation stuff that we have studied for fully connected layer remains same, but we just need to take care of this weight sharing. So W transpose here is equivalent to, it's like I have kernel K or F here, then I have to just flip the kernel, then compute the entire, it's like compute the convolution operation. Okay, so I have A and then used F, computed the convolution sum by sliding this F on A. Similar thing we do while we compute the backprop. Okay, when we pass the gradient through one convolution layer to the previous convolution layer, we carry out the same sliding operation by flipping the kernel. But that's not required. But if you are figured that out after working out some exercises, then you can go ahead with it. But in exam, I would even suggest to go write down the things explicitly to avoid mistakes.
Okay.
But I take a look at the post whether.
Sir, but unfortunately I cannot find it. I searched a lot, but for some reason I can't find it again.
Okay, no issues. So now we just focus on Quiz-2. There's no exam.
Yeah.
So, sir, one thing I would like to highlight what Hanani was saying is basically convoluting is creating this sum product only, right?
Yeah.
So you are ultimately doing the same thing if you have multiple derivatives present. So if you convolute, it will be easier to get the nabla faster. I mean, that is why convolution is being done at the last step.
So you
So here it
mean when
is
you compute
derivative
the
is one
backprop?
only. Yeah.
Mm.
Yes. So here it is only in the one position. It is one. So you are
Yeah.
expanding it. If you have multiple
Yeah.
position having derivative, if you convolute, you are doing the same thing only.
Yes.
So
That is, I mean, in the Quiz-2, I think you can apply this concept.
yep.
Which concept, sir? The concept of
Now here
writing
we are
the
writing
expression.
the.
Are you saying, sir, in Quiz-2 we have to apply the concept of writing out the expression instead of using convolution in backprop?
No, I would say you can go ahead with anything. So what Debo Priyosaha is telling is that, see, it is like we have discussed about this. I mean, when you compute the convolution sum with x and f, right? Which one you prefer? Whether you write down a10 explicitly for each element a00, a01, a10, a11, and then write x10, w0, and then compute the way, or you place this filter on top of x and compute element wise multiplication and add for just for while we doing this manual computation, which one is quicker? Both will give you the same result, but we prefer this way, right? We place the kernel on top of it, do dot product and sum it up. Sorry, you just do element wise product and sum it up. This is seems to be quite easier, and also may not be prone to error because we are doing all this computation carefully. Then this writing down this expression and plugging these values and then computing all this, right? So
Yes.
same thing you can do for computing the gradients for this, computing gradient and passing the values to the next layer. You can carry out the convolution operation using this kernel. Okay, but for now you are just, if you are just getting started with computing or getting familiar with how to compute this gradient for convolution sum, I would suggest you to stick with this approach. Write down the expression explicitly and stick with that, given that we have exam tomorrow. Otherwise you can experiment, you can see how you can optimize all this computation. Okay, so in exam, I keep advising you, write down everything on paper, don't do any mind calculation, and do not try to, guess the answer by thinking whether can we, get the answer if I do this step or that step. You just take a first step, there are always first step, right? You identify the required formula or required concepts and you take a first step. By taking first step, either you end up seeing patterns or you will end up with answer. But if you're just doing everything in your mind, you may not get the answer. Okay, and even if it is a simple calculation, write it in the paper, don't do mind calculation. Okay, that's my advice. Okay, yeah, so this computing the parameters for the convolutional neural network and computing the gradients for a simple convolution operation is an inevitable component in all the exams, and please pay attention to this. And as I mentioned in the beginning of the session, that if you have solved the questions in the Quiz-2 of previous two terms, then you should be able to get mark around 60 to 70. But if you want to go beyond that, of course you have to solve some more questions, okay, which are quite new. I mean, conceptually they are old, but the question slate is kind of twisted. Okay, so if you have any question related to Quiz-2, okay, just avoid the general questions. So if you have any question related to Quiz-2, you can go ahead, or you can go and work out the exercise. So I see in the WhatsApp group that most of you are working on these two questions.
I had posted a question about earlier.
Where?
In the chat. How do you?
Oh, okay. I'm not looking at this chat of this. Okay.
719. So basically, slide 68 of the actual lecture, right? Where there is a picture and then various parameters are missing. So it was a bit confusing, right? Suppose you are asked about what are the parameters of conv2 layer. At least I was getting a bit confused where to start from.
Okay. So
you could probably take the slide 68 from the lecture, and that itself as a good example.
Okay. So the parameters are always the kernels, right? So whether it is a, see, I'm just telling you the general thing. Let me. Okay, I'm not able to delete. Sorry, I was not able to delete this. Okay, so let me try to explain whether you're able to get that. I have an input, right? X. So I have an input X, and then with either 3 channel or n channels, and then I take a set of filters which belongs to convolution layer 1. Okay, so which means you have to apply these filters on the input, and then it generates a set of outputs that we term it as an convolution layer 1. Okay, so the number of parameters belonging to convolution layer 1 is the parameters in these kernels which helped us to produce this convolution layer 1. Okay, of course that includes all this activation and max pooling. When we say it's convolution layer 1, it includes the future map as well as this max pooling operation. Okay, so together we can pack it as a convolution layer 1 because max pooling doesn't depend on the parameter. It is not parametric calculation, it is just a single operation. So if I ask you how many parameters are there in the convolution layer 1, means that we are just telling you how many parameters are there in the kernels which produce this convolution layer 1. It is not the elements in the convolution layer 1.
No, I get that. So the question, the quiz has been about convolution layer 2.
Okay. Now you apply set of kernels on convolution layer 2, sorry, convolution layer 1, maybe after max pooling layer. Okay, so you apply max pooling, you will end up with a reduced feature map. Then you take some set of kernels, okay, that could be some 30 kernels or whatever. Then you apply the operation on this max pooling, output of this max pooling layer. Then, you know, that generates the convolution layer 2. Then if the question is about how many parameters are there in convolution layer 2, then it means the kernels corresponding to these operations, right, which produces this convolution layer 2, all the future mappers in the convolution layer 2.
So in a way, I look at the output of convolution layer 2 to figure out what are the parameters of it. Or can I just show the slide, please, if it is okay with you? Can I just present the slide?
Okay, so I am just searching for it.
Or I have it right there. I can.
Okay, you can share it. Then that's better. I'm not able to close my presentation. Okay, here. Yeah, please, you go ahead and present.
Sorry, yeah. Okay, I moved off somewhere. Right, so this is one part, right? Okay, sorry. I'm sorry. Okay, this one. Yeah. So how do we get 2400 here in the convolution layer 2? So this is where I was. I tried to watch the lecture also, but I still couldn't figure out.
So in the group, someone pointed. I mean, whether you are asking how is, this 2400 is coming, or
yes,
you are getting a different answer other than 2400.
No, sorry. Because the quiz question also is very similar. It had a very similar network, right? And you was asking about convolution layer 2 only.
Okay, so from the diagram, let me start with the first convolution layer. Okay, so the input is going to be 28. It's convolution layer 1. How many filters are? What is the depth? And depth is 1. Yes, 1. 5 filters are there. Okay,
yeah, so 5 into 5 into 6. So that is clear.
Yeah, 5 into 5 into 6. Okay, here it is. Filter size is 2, but it's not parametric. Then here filter size is 5. Okay, is that 5, right? Am I reading correct?
It's 5.
Okay, so filter size is going to be 5 by 5 into 14. What is the depth of max pooling, previous max pooling layer? It's 14, right?
6.
14 by 6. So okay, so if the depth is 6, then the filter size for convolution layer 2 is 5 by 5 by 6. So there are 16 such filters. So 5 into 5 into 6, 150, and there are 16 filters. Okay, 2400.
Okay, so
but there should be a bias also. I don't know why.
No, in the lectures there is no bias, right? So generally it doesn't use bias in the lectures.
Okay, it is nowhere they use the bias term.
No, sir. That is why we are saying like in quiz we are shocking with the term bias with the kernel.
Okay, so if I'm not wrong, I think in the starting of the lecture he discussed about that, convolution in general. So in the weight sharing approach. So I thought they might have discussed about that there.
No, sir. Nowhere it is mentioned about the bias with the kernel.
Okay. So maybe I didn't get that because it's going to be W and B, it is always W and B. So just it's a weight sharing, and weight is shared, bias is there. So I thought it should be able. I mean, maybe I should have given this as an exercise in the assignment. In the assignment question also, we are not using any bias in the kernel. If I'm not wrong, can anyone confirm?
No, sir. We haven't seen bias anywhere.
Okay, then I have to update the assignment question. So it is, once again, I hope now we are all familiar with that bias term, if I'm not wrong, after solving all these questions, right?
Okay, so sorry, one more, same thing. So now you're saying 5 and 5, that is the stride of the convolution to layer 2, that is fine. Into 6 because of the channels from the previous layer.
Yes.
And then into 16 because of the current one. So in a way, the kernels keep getting multiplied. Right? If you have one more layer, it will be similar because it will be 16 and then it will again get multiplied.
Yes, that's correct. See, conceptually, that's how everything is. Okay, so let us discuss after quiz 2. But if that makes clear to you right now, that's fine.
Yeah, I'll just remember that as an abstract one. Thank you so much.
Okay. Okay. Because in the beginning of the lecture, there was a motivation, right? Why we use weight sharing and why we go with that. All these things were discussed in the beginning of the lecture. So that's the motive lies. Okay, so if you understand that, then you can connect everything. I mean, this entire CNN with the fully connected layer. So you can correlate all these things. I would say it is not at all different from fully connected layer, except this weight sharing. So you can apply whatever you learned in feed forward fully connected neural network to CNN. It won't make any difference. But now you don't do that. You just focus on the exam, and we may discuss that later. Okay, so please solve all the quiz 2 questions, especially this convolution, all these stuffs. Ensure that you understand all the calculation and you are able to reproduce them if it is being asked in the exam. Okay. And all the best for all. I upload the recording. Maybe it takes 30 to 40 minutes for me to upload this recording in the deep learning channel. Okay.
Thank you, sir.
Yeah.
Sir, I have like a doubt little bit. If it is mentioned like take bias as something value, and for like convolution uh, uh, for that, so we have to consider for kernel also, or in the exam somewhere.
Sorry, which means you are asking if we ask you to consider bias value, you have to consider the bias value for the kernel.
Yes, sir.
Yeah, you have to consider it. Say, for example, to make things clear once again. Okay, you are given some matrix X and the kernel K, a very simple kernel. So when we say you consider bias for the kernel, so what we are simply meaning is that you place this kernel. Okay, you do all this dot product and then add bias plus b, and then you make a stride, do all dot product and add plus b. So for each of these operation you have to add this plus b.
And for like for number of parameters, we have to consider bias also, right?
Yeah, for a single kernel there will be only one bias. The kernel might contain some n elements. Say for example, if it is a 3 by 3 kernel, there are 9 parameters or 9 weights and 1 bias. Okay, if it is a 5 by 5 kernel, then there are 25 weights plus 1 bias. So we often try to distinguish parameters. When we say parameters, it is often, okay, it's weights plus bias. Okay, so we try to follow this notation consistently. But in your case, yeah, this is how things goes. So for each kernel, there will be one bias. So if there are 10 kernels of size 3 by 3, then for each kernel, there will be only one bias. So totally, the number of parameter is going to be, for each kernel, it is 3 into 3 plus 1, right? So 10 elements. So it is going to be 10 into 10, 100 parameters altogether.
Okay, sir. So we don't have to take like in the example you have shown us, we add bias to individuals, to individual like A01, A00 and all. So we don't consider all the like bias different as a different parameter.
You need not. So just for Calvin, it is like I compute all these things and then adding an element B in the
But
final step. You don't need to consider that as 4 additional parameters.
okay, sir.
Okay, so that's not, it is not counted towards number of parameters. Number of parameters are only with respect to the kernels, not on these operations.
Okay, sir.
Sir, one conceptual question. In RMS prop, we have momentum adding exponentially, right?
RMS prop. Momentum
Learning rate exponentially growing.
Yeah, it's decays exponentially. Yes.
So, like, is it monotonically increasing or like decreasing, or it varies?
The exponential decrease is going to be monotonic, meaning that
So the learning rate always like only monotonic decrease only, right?
no, it depends on the gradient rate. So that's where one of the question is. So if we ask about whether it is monotonic increase or decrease, yes, the answer is true. It's monotonic increase and decrease. So you have Wt minus eta by some square root of Vt plus epsilon. Then you compute Vt, right? I think we have beta Vt minus 1 plus 1 minus beta gradient of Wt square, right?
Yes.
The thing is that it is function of um, gradient. Suppose if the gradient profile of the law surface is something like this, okay, it is keep decreasing something like this, just for the sake of argument. Okay, my gradient also decreasing or increasing monotonously, then V2 also follows the same. It increases or decreases monotonically. So the monotonicity is there. So if I understand your question, if you are concerned about this monotonicity, yes, it is monotonous. But if you ask me whether VT will increase, because monotonous means either it is increasing, decreasing monotonously or increasing monotonously, right? You will not you see something like this.
So the learning rate as such either increase or decrease. Is it so?
Yeah, it increase or decrease based on the gradient profile, how the law surface is at various instant of time or iteration.
So, I'm sorry. The VT term of RMS prop, won't it decrease as well as increase? I think that was one of the disadvantages of RMS prop. As we approach to the minima, the learning rate just oscillates there. That is why we went from RMS prop to ADA delta. So I think in the
Yeah,
case
that's
of
what we said. It could either decrease or there could be a chance it could increase based on the the slope of the last surface at that point of time. So that it increase, decrease, or even it remains constant and oscillate back and forth if it is really bad
and
local.
this is true because beta is lies between 0 and 1. That is why the VT term of RMS prop will increase and decrease. Is my understanding correct?
Yeah, beta is restricted to, I mean, it is a convex combination. If to be strict, it's something like that, and it is restricted to between 0 to 1. That's true. That's where we mentioned, if I remember correctly, we mentioned this. There is a chance that learning rate could increase or decrease or remain constant, where it gets stuck. Maybe it keep oscillating. Okay, that is true for RMS prop, but in ADAGRAD there is no chance. It always the initial or the effective learning rate, right, of RMS prop is always keep decreasing. It never sorry of ADAGRAD, but RMS props it could increase.
Got it, sir.
Yeah. So if suppose that we frame the question around this concept, then we have to give you the gradient profile. Without giving you the gradient profile, we can't, in general, we can ask whether it increase or decrease. You can answer, yeah, it can increase or decrease. But if you really want to apply this idea to a specific situation, then we have to give you this gradient profile. We give you some 10 elements, right? Then we ask whether it keeps decreasing or it is increasing at particular iteration. Further, you have to make use of this gradient at various time steps.
Okay, sir. Got it. Thank you.
Yeah.
So generally, you would be giving the update rule for these different algorithms, right? Or we have to memorize?
No, you need not to memorize. So RMS prop, I think it's okay to remember, but others, right? So Adagrad RMS prop is expected. I mean, it's not a big deal to remember it.
Yeah.
But for other optimizers, we give you the update rule explicitly. If you frame some question around VT, right, then we have to give you all these VT and equation for update. And if you are framing question around MT, see in the case of Adam, then we list out you what's MT looks like. We may even modify it if we want it. That you might have observed in the previous questions, right?
Yeah. Okay.
Okay, so all the best for your examination. Don't be panic. And telling you, sorry, I'm repeating this once again. Just solve the previous term quiz questions. You are guaranteed to pass with at least BAT 62. I'm not quoting any marks, but you will be able to pass this quiz 2. Okay, but typically quiz 2 is perceived more difficult than quiz 1. But now I am telling you, if you solve the previous, then you should feel at least 60% comfortable with the questions of the entire quiz 2. Okay, so it is not completely, it is not going to be completely strange. Okay, so you know how to proceed for some of the questions. For the rest, you need to apply the existing knowledge. Okay, so I upload the recording now.
Thank you, sir.
Thank you so much for the help. Yeah.
Yeah. Thanks.
All the best to everybody in the quiz. Yeah.
Thank you.
Thank you.